Good day to you. This is teacher Leland, Alejandro, and we'll be discussing linear programming problems. So linear programming problems involve mostly something that has money computation or involving money or profit. And usually this will have constraints or inequalities, okay? And this is more on maximization or minimization problems. So we're going to see the linear programming problems in the other screen. Okay, so we can start with the problem set. Okay, let us see it over here. So this is the first number under linear programming word problem. Okay, a manufacturer of ski clothing makes ski pants and ski jackets. So we have two variables here. Okay, the profit on a pair of ski pants is $2, and on a jacket is $1.50. So $2 for pants and $1.50 for a jacket. Both pants and jackets require the work of sewing operators and cutters. So this will be involving sewing and cutting. Okay. There are 60 minutes of sewing operator time and 48 minutes of cutter time available. It takes 8 minutes to sew one pair of ski pants and 4 minutes to sew one jacket. Cutters take 4 minutes on pants and 8 minutes on a jacket. Find the maximum profit and the amount of pants and jackets to maximize the profit. Okay, so this will be the worded problem. All right, so letter A, let X equals ski pants and Y equals ski jacket. So we're going to use the variable X and the variable Y. Since there cannot be negative pants or jackets, write two inequalities to represent the situation. So since there will be no negative, so we can use something like this, okay? All right, let us start here. We can make use of X, okay? That should be greater or equal, okay? Greater or equal to 0, okay? It cannot be negative. And then for the other one, for the Y, okay? Okay, same thing. X, this time it's the for the jacket, so this will be for the Y. That will be greater or equal to 0. Okay, all right, that should be for our answers. And why don't we change the color for this? All right, let me see if I could change the color. Okay, let's have this like let's have this red. Okay, change it to red. All right, so let's see if I could change it. There, all right. And let this be black again. There, okay. So that goes to the letter A. Let's have the letter B. All right, here's the letter B. Express the cutter's time to make pants and jackets as an inequality. All right, so this will be the cutting time. All right, so let's go back to the problem, and we can see there are 48 minutes of cutter available time. Okay, uh, that will be for the cutter. Now, in the second to the last statement, we have cutters take 4 minutes on pants. Okay, now X is for the pants. Okay, so we're going to make use of 4 minutes. Okay, that'll be 4 times X. Okay, 4 times X plus 8 minutes for the jacket. So that'll be 8 times Y. Okay, and it cannot exceed 48 minutes of cutter time available. So this will be, of course, less or equal, okay, to 48 minutes. Okay, maximum is 48 minutes for cutting time. Okay, for both jacket and pants. Okay, so this will be our uh, letter B. Okay, this will be our letter B. Okay, let us go back to our red. All right, red. Okay, that's it. All right, so let's proceed to letter C. Express the sewing operator's time to make pants and jackets as an inequality also. These are the constraints. And there are 60 minutes of sewing operator time. All right, so going back to the sewing, okay, this will be the statement. It takes 8 minutes to sew, okay? All right, over here. It takes 8 minutes to sew one pair of ski pants. So that means we're going to have 8x, and then we have, that'll be for the pants. And 4 minutes to sew one jacket. That means we have the 4y. And for sewing, the allowed time will not exceed 60 minutes. Okay. All right. Under the third line here, there are 60 minutes sewing operator time. Okay. And so this will be again less or equal to 60 minutes there. Okay. All right. Again, we shall transform this to something like red. Okay. All right. Let's put this red, red, red. There. All right. And then let this return to black. That should be. Let me change that. There. Okay. All right. And then let's return to the red. Okay. Red. There. All right. So I hope it remains red for the next statements. All right, and so we're going downwards here. So let's go downwards. Write an equation for the anticipated profit. Okay, we can find that the second statement. The profit on a pair of ski pants, okay, is $2, and a jacket is $1.50. All right, so all we need to do is $2 times X. Okay, so that will be $2 times X. All right, this will be for our profit statement. 2x plus 1.5 for the $1.50 times y. Okay, and this will be for our profit. So we will just have capital P is equal to 2x plus 1.5 y. Okay, because x represents the number of pants and y represents the number of jackets. Okay. All right, so that will be it for our profit statement, and then this will be red, of course. All right. Okay, all right. We finally have our answers there. Next, graph the constraints. All right, graph the constraints. Okay, we can go to another screen, the Desmo screen, which will facilitate our graphing. And so all we need to do is get the copy of the entire worded problem, and then let's proceed to that screen. All right, so we're going to have a new share, and we're going to that screen. All right, here's the screen where we're going to have our solution. All right, and so, all right, let us put our problem over here. Let's use the annotate, and then to be text, and then over here. All right, let me paste it there. All right, so that's it. All right, so we can see it over here. All right, so we can begin with the profit statement again over here. We'll just type it. So this will be P is equal to 2x plus 1.5 y. That'll be for our profit. And then what else do we have? We have the cutter time and sewing time. All right, so let's start again with the cutter time. That'll be 4 minutes for pants, and so that will be 4x. And then we have 8y, all right, for the jacket, and cutting will not exceed 48 minutes, okay? Will not exceed 48 minutes. So we will have the less or equal there, and 48 there, okay? All right, this will be our first constraint graph, okay? and this will be for the cutting. Okay, 4 minutes on pants, 8 minutes on the jacket, and cutting will not exceed 48. All right, now let's go to the sewing. All right, so we have allowed allowable 60 minutes for sewing, and that will be 8 minutes to sew pair of ski pants. So we will have to start with 8x plus 4 minutes to sew one jacket. So that means 4y there. And this will be less or equal 60 minutes there. There. Okay, so these are our constraints. All right, we don't forget that the two variables, okay, cannot be negative. And so we will have to include some more. Okay, we will have to include uh, x cannot be negative. So that means greater or equal to 0. Okay, and also the jacket cannot be negative. It can be none, okay, but not negative. All right, there. All right, and so we have chosen these constraints, which we already have in the other screen, but let us change the dark color there. Let's try to change it to, say, orange. Okay, I think it looks better with the orange there. Okay, all right. Okay, this will be the graph of our constraints, and you can see the graph here. All right. Now, the way to solve for the required maximum value or maximum profit, we will be using the corner points of our feasible region. Okay. All right. Take note, the inequalities will have the feasible region. Okay. Here. All right. For our graphs. All right. There. That means this portion here is our feasible region. This is like this, like that. Okay. The inequality for the blue and the green. Okay. Now it cannot be negative for x and y. That means, all right, this will be for the jacket. Okay. It cannot be negative. Also for the ski pants. All right. There. It cannot be negative. There. Okay. All positive values for x and y. And then this is actually for the times for sewing and cutting. All right. Now our solution will be dependent on the corner points. Okay. And we can find these corner points over here. There. Okay. These are the corner points. There. There. Okay. All right. These are the corner points. One of these 4 points will give us the maximum profit. Okay. And we're going to make use of the statement over here. Okay. And this is actually what we're going to use, this portion here. There. And then we're going to try all these values. Okay. We're going to try all these values. So let us try it. Starting with 0, 0. Okay. Over here. All right. Starting with this one. This is 0, 0. Okay. That's 0, 0 there. All right. So if we will use 0, 0, this will be for the P is equal to something like 2 times 0. Of course, this will be 0. And this is $1.50 times 0, like that. So our profit there is 0, okay, for this particular point over here. Okay, our X, okay, is 0. Our Y is 0. There, okay. And so our profit there is 0, okay. Now, that's not maximum. Let's try another point over here. That's 0, 6. Okay, 0, 6. All right, so we're going to use the profit statement again. This will be P is equal to 2 times, all right, 0 plus 1.5 times the 6. There. Remember, our point is right here. Okay, our point is right there at 0, 6. That means 0 for x and 6 for y. And if we use this statement, 2x plus 1.5y, we obtain a profit of $9. Okay, all right. So let's proceed to the other point. Okay, how about this one? This is 6.3. Okay, 6.3. Okay, we're going to use it over here. All right, 6.3. All right, let's remove this red mark here. Let me remove this. Okay, because it doesn't encircle the profit statement anymore. All right, so this will be P is equal to 2x. Our x is 6, yes, 6, and then plus 1.5. All right, our y is 3, okay, 6, 3. Remember, it's over here, there, 6, 3. All right, and so this is our current point, all right, and we shall determine if the profit is maximum over there. All right, we have there $16.50, okay, 16.5. Now we're not yet done. We have one more point over here, okay, that's 7.50. So that means x is 7.5 and 0 for y. All right, we still have to compute the profit for that point. And so this will be our fourth computation. P is equal to 2 and 7.5 plus 1.5 times 0. There. So these are the computed values. We now have all those 4 points, okay? We first calculated here, and then over here, and then over here, and then over here, okay? All right, so let us show the coordinates so everything will be clear. All right, these are the points we have chosen. Okay, we have chosen these points. Okay, all right, let me display everything properly. And it slides down over there. Okay, let me just remind you, this is the 0, 0, okay? 0, 0 there. All right, so that will be for this point here, okay? For this point here. And then this is 0, 6, and that's for this point there, okay? All right. Now, the third is 6, 3, okay? It's over here on this point there, 6, 3. All right. And then for the fourth computation, we have the 7.50, and that's for this point there. Okay. So we have 4 computations, and the results are 0, 9, 16.5, and 15. And obviously, we have the maximum there. This is the maximum, $16.50, and that belongs to the point 6.3. Okay. Over here, 6 and 3. All right, and so that will be our maximum. Okay, all right, so let's return to our screen. Okay, let's go back to our screen there. Okay, here's our previous screen, and we just finished letter E, graph the constraints. All right, there. Now we have chosen the corner points. Okay, we have chosen the corner points. Use the corner, that will be for F. Okay, use the corner points to find the maximum profit, and we just finish getting all those corner points. And if we're going to enumerate those points, okay, if we're going to enumerate that, then we shall type it over here. All right, so those corner points are 0, 0. Okay, as far as I can remember, is 0, 0, and the other one is 0, 6, and then the third is 6, 3 there, and the fourth point is at 7.50. Okay, there. Obviously, we cannot have 7.5. Okay, we have to round down. Okay, that can only be 7. There's no 7.5 pants. Okay, there. So if we use 7, remember, we cannot go over that, okay, because that's the corner point. We cannot have 8. So it can only be 7, round down. And if we use 7, surely it cannot be the maximum, okay, because we already computed it, and the maximum is at 6.3, okay? 6.3 is the maximum. So these are the corner points, and that's our corner points in the graph. And letter G, what is the maximum profit? As far as I can remember, that's $16.50. Okay, so that's the maximum profit. So that's $16.50. That's 16.5. So that's our maximum profit there. All right, so that should be colored red. Okay, okay. How many ski pants? All right, of course, that would be 6. Okay, how many ski pants? That would be for the X. So we have 6 pants there. And how many jackets? That would be for Y. Of course, that would be 3 jackets there. Okay, these are the answers. And that goes to letter H. Okay, all right, so we can have that also over here. We can have that over there. Okay, all right. How many ski pants and ski jackets? All right. Okay, so we can now proceed to our next. Here's number 2. Okay, this will be our number 2. All right. The automotive plant in Rockaway makes the Topaz and the Mustang. The plant has a maximum production capacity of 1,200 cars per week. During the spring, a dealer orders up to 600 Topaz cars and 800 Mustangs each week. If the profit on a Topaz is $500 and on a Mustang is $800, okay, determine the maximum. Okay, determine the maximum. All right, so we're going to check this. Okay, all right. Okay, so this will be X. This will be for the Topaz cars. Okay, all right. So this will be for the Topaz cars, and Y for the Mustang. Since you cannot have negative cars, write 2 inequalities to represent situation. All right, so first we shall type something here. Okay, so this will be for the first, this will be the Topaz there. And for the Y, of course, for the Y, that will be, okay, this will be for the Mustang. Okay, there. Then we shall color this, of course, we shall have it red. Okay, see if we can make it red there. Well, the previous, we were able to make it red for our answer. All right, there. And then this will be for the Mustang there. All right, this will also be red. All right, so at least we're consistent with the variables. And since you cannot make, or you cannot have negative cars, write 2 inequalities. All right, I would say X is greater or equal to 0. Okay, greater. That means cannot be negative. Also, the Mustang, Y is greater or equal to 0 there. Okay, and then we can have this colored red. Okay, so that all right there. Okay, all right, so letter B, since the plant has a capacity of 1,200 cars, write an inequality to represent the situation. All right, so capacity of 1,200 cars, that means it cannot exceed 1,200 cars per week. And so we shall just add the Topaz to the Mustang. Okay, and this should be X. This should be a small X like that. All right. And so this cannot be exceeding 1,200 cars. So less or equal to 1,200 cars there. And this must be the required inequality. Yes. Write an inequality to represent the situation. So this is our inequality. Let's just color it red. That's it. And then letter C. Since the dealer orders up to 600 Topaz and 800 Mustangs, write two inequalities to represent the situation. All right. So up to, okay? The dealer orders up to, okay? Up to 600. All right. So that means it cannot exceed 600 for the Topaz, and it cannot exceed 800 for the Mustangs. So this will have to be 600 the maximum. All right. So this will now be like X. Okay, over here. Let's go down over there. X must be less or equal to 600, and the other one will be Y. That's less or equal to 800. Okay. All right. So 600 at the most for Topaz, 800 at the most for the Mustang. So this will be for our inequality. And we shall have this like red. Okay. There. All right. That goes to our letter C. Answer. Write an equation write an equation for the profit. All right. How about the profit? How much is one Topaz car? All right. For a Topaz car, it's $500, and Mustang is 800. All right. So all we need to do is multiply 500 by X. Okay. $500 for. I guess these are old prices because. All right. Yes, it's too small. 500 for a car. This must be sometime about several decades ago. All right, so this is 500x and plus 800y there. And this equates to our capital P there, okay? All right, there. This will be our profit equation. Remember, this is an equation. It doesn't involve the less or greater symbol, okay? This is an equation. And we shall just paint it red. All right, there. Okay, so that's it. Now, we now have the letter E part, graph the constraints. Okay, we will be doing this in the other screen. Before we do that, let's continue with letter F. Letter F, use the corner points to find the maximum profit. And then for G, how many types of each car are needed to maximize the profit? Okay, and how many of these cars for each type? Okay, so that goes to our letter G. And then letter H, what is the maximum profit? Okay, all right. Okay, all right. So I think that will be it. And letter E is graphing. Letter F is to determine the corner points. Okay, the corner points is just what we did in the first problem. And then letter G, how many types of how many cars for each type, I think. All right. And so what is the maximum profit for the last question? All right. So we're going to do what we just did for the first number. Let's get the worded problem on the screen of the Desmos so that we can rewrite those constraints. All right. There. Okay. And so we shall do a new share in the Desmos file. There. All right. This is still the graph of the first problem. And what we need to do is just clear this out first so we can have another graph. All right. Let me just clear it first because that belongs to the solution of the first problem. Here comes the second problem. All right. Over here. All right. There. Okay. I hope you can see it clearly. All right. Over here. The automotive plant in Rockaway makes the Topaz and the Mustang. The plant has a maximum production capacity of 1,200 cars per week. During spring, a dealer orders up to 600 Topaz cars and 800 Mustangs each week. If the profit on a Topaz is $500 and a Mustang, it is $800. And then there's no other statement there. So we're actually looking for the maximum profit here. All right, so we shall have the statements over here, starting with the constraints using the 1,200 cars. So for that one, this will be X plus Y, all right? And it cannot exceed 1,200 cars. So this will be less or equal to 1,200 cars. All right, so we cannot see the line, okay? So we might as well do a zoom out, okay? Let's do a zoom out there and find out the line. Because our numbers great at 12. There, I saw the line already there. Okay, all right. Okay, so 1,200 will have to be right over here. There, okay? That's the level for 1,200. Okay, let me clean that part. All right, and so this is our inequality, and the arrow here will have to be going here like that. Okay, like that. That means the shaded region will be the part that will include our solution. Okay, not the portion over here, not the portion there. Okay, all right. So all right, and so this will be our first constraint graph. We shall continue with a second. All right, during the spring, a dealer orders up to 600 Topaz cars and 800 Mustangs each week. Now, it cannot exceed 600 Topaz cars, okay? Also, it cannot exceed 800 Mustangs. And it cannot be negative, okay? It cannot be negative. And so we can make use of the inequality, all right? Since it cannot be negative, that means it will be between 0 to 600, okay? It will be something like this. Less or equal, this will be for X, that is representing the Topaz cars, less or equal 600. There, okay? So only within this vertical region, all right? This will be for the Topaz cars, between 0 up to 600, okay? It cannot be lower than 0, which means negative cars, okay? This will be for the Topaz cars. Now, the next one is up to 800. So from none to 800. So again, we shall use 0 less or equal y less or equal 800. There, okay? And then for the fourth statement, we shall have the equation for the maximum profit. That will be 500, okay, for the price of the Topaz car. All right, so this will be represented by X, and then we have plus, we have 800 times Y there. All right, this will not reflect in our graph, okay? All right, and so we can see here our region, okay? Our feasible region will be this portion here. All right, so this will be over here. All right, let me put the arrow. Now we shall erase this part here and this, okay, because it's above the region for the Y, okay, for the Mustangs, okay. All right, so exactly to be exact, it will have to be this region, okay. I'm going to show the boundary. All right, there, over here, and over here, okay? There. That'll be our feasible region, okay? Anything outside of this will not be part of the solution, okay? All right, and so we have how many corner points? We have 1, 2, 3, 4. We have 5 corner points, and so that means we're going to use this uh, profit statement 5 times. We will have to compute 5 times. 1, 2, 3, 4, 5 corners. And we have uh, 5 corners, and so we will have to compute 5 times. Okay, this is the feasible region there. Okay, outside of this feasible region will not be part of the solution. Okay, only inside. Okay, the corner points will provide the maximum. Any point inside this region will just be in between the minimum and the maximum. Okay, all right. So the corner points will give us the maximum. Okay, all right, or the minimum. All right, and so we shall make use of the first point. So let us begin over here. Okay, it starts with 0 and zeros. That means our profit there is 0. So if we use that 0, 0, of course, we will just show it. So this will be 500. Of course, we know that will be 0, of course. This is 800 times 0. There. All right, next, we shall proceed to this point here. Okay, this point is 0, 800. Okay, 0, 800. That means 0 for x, 800 for y. All right, over here. P is equal to 500 times 0 and plus 800 times, what's the point again? What's the point again? That will be 800, yes. So I'll just put it here, 800, there. And so our profit there is 640,000, okay? 640,000. All right, so we continue with the next point. Next point is over here, there. That'll be 400 for X and 800 for Y. So we shall use our profit statement again. And we have 500 times 400, okay, plus 800 is the price for one Mustang. And then this is, what is this value again? 800, okay, yes, 800. That's 400 and 800. All right, so this is another 800 over there. And so the profit here is 840,000. Okay, all right, let's proceed to the fourth point over here. This is 600, 600. Okay, so this will now be, this will have to be used for the same profit statement. 500 times 600 plus 800 times 600 again. We have 780,000. 780,000. All right, that is not the last point. We still have one more over here. That's 600 and 0. Okay, 600 and 0. All right, so we shall proceed over here. P is equal to 500 times 600 plus 800 times 0 there. Okay, and so these are the different computed values. All right, let us start reviewing them. We have 0 for 0, 0, 640,000 for 0 and 800. And then we have 840,000 for 400, 800. And then we have 780,000 for 600, 600. And finally, we have 300,000 for 600 and 0. So which one is the highest? Looks like we have the 840,000, which means 400, comma 800. That means 400 Topaz cars and 800 Mustangs. Okay, so where is that? It's over here. This will be the solution, and this will be the X, and this will be the Y, okay, which stands for the Topaz and the Mustang. All right, and so I wonder if we still have those cars. All right, I think we still have Mustangs, okay, all right. So All right. So we have 840,000. That would be for the maximum. Okay. You can see it's the highest value there. The minimum, of course, is zero there. Okay. And so, all right. For curiosity only, how about if we choose something inside the region? Okay. How about trying something like that? Okay. All right. Just for curiosity. All right. What if we use a point inside? Okay. 100, 100 over here. Will it give us something more than 840,000? All right. Let's just try it. Any value inside will not be maximum. Only the corner points can provide that. Okay. And so if you try that, this will be 500 times 100 plus 800 times 100. All right, what do we have? It's only 130,000. Okay, so you cannot get any higher than 840,000. Okay, if you choose any point inside the feasible region, okay, it will have to be this. Okay, this is the solution there. That's 840,000. All right. So we will just remember our solution: 400, 800, and then 840,000. All right, and so we shall go back to our screen. Okay, let's go back there. We have the answers already. Okay, and over here, use the corner points to find the maximum profit. We will not enumerate the points anymore. We will just write the maximum profit. The maximum profit is $840,000. So that's $840,000. Okay, and we have 400 Topaz cars, yes, and 800 Mustangs. Okay, this will be for X, and this will be for the Y there. Okay, so this will be for the Topaz, and this will be for the Mustang. Okay, Mustang. Yeah. All right. So these are our answers there, and 840,000. That'll be okay. All right. So what are those points? As far as I can remember, we started with 0, 0. We also have 0 and how much is that? 800. Also, we have something like 600, 600. Yes. And then for our maximum profit, we have 400, 800. And then for our fifth and final point, we have 600 and 0. Yes. That's what I remember from the other screen. Okay, and we shall color this red. Okay, red. Okay, that's it. All right, let's continue with how many types of each car are needed. Oh, we already answered that. We have 400 Topaz and 800 Mustangs. What is the maximum profit? $840,000. All right, so we're going to the next problem, our third. Okay, here, a farmer has a field of 70 acres in which he plants potatoes and corn. Okay, the seed for potatoes costs $20 per acre. The seed for corn costs $60 per acre. And the farmer has set aside $300 to spend on seed. The profit per acre of potatoes is $150, and the profit for corn is $50 per acre. All right, or $50 an acre. Find the optimal solution for the farmer. Okay, so farmer has an available space of 70 acres. Okay, so acre is larger than a hectare. Okay, so all right, so we have 70 acres. That should be maximum. Okay, in which he plants potatoes and corn. So let us make use of X for potatoes and Y for corn. Okay, there. and it will have to be the number of acres allotted for potatoes and the number of acres allotted for corn. Okay, so that will be our variables. Okay, so we shall just add here x. Okay, this will be for number of acres to be used for potatoes there, and then the y will be the number of acres for corn there. Okay, because it did not specify the variable, so we're going to make use of these variables. Yes. All right, there. And let's paint it red. Okay, there. All right. Write the constraints for the problem. Okay. First, the maximum is 70 acres. So that means the number of acres allotted for potatoes added to number of acres allotted for corn will be at the most 70 acres. Okay, so less or equal to 70 acres there. And this will be our, let's make that small letter X there before I transform it to red color. There, okay. So we have there X plus Y, number of acres for both potatoes and corn, at the most 70. It cannot exceed that because that's the available field for the farmer. Okay, the seed for potatoes costs $20 per acre. Okay, so we'll be able to make use of this amount. Okay, and the farmer has set aside 300 to spend on seed. All right, and so we can make use of another constraint. Okay, write the constraints for the problem. We still have one more. $20 times the $20 times the number of acres. This will be some amount. Okay, plus that will be for potatoes, and then we have $60 times y acres. That will be the amount for seeds. Okay, and the farmer has set aside 300 to spend on seed. That means 20x plus 60y cannot exceed 3,000. Okay, this will be less or equal 3,000 there. Okay, this will be our constraint. All right, and so anything else? Number of acres, it cannot exceed, it cannot be negative. There's no negative area. So we can still use x greater or equal to 0. Also, y is greater or equal to 0. There. Okay. This will be for our constraints. These are inequalities. Okay. All right. The next will be equation. Okay. The equation. All right. The profit for potatoes and corn. So 150 per acre for potatoes and 50 per acre for corn. So we have 150. Okay. We will have here profit is equal to 150 for the, what is that, corn or potato? Potato first. All right. So that'll be 150 and x, and then we have 50 times y there, the profit per acre. All right. And so this will be our profit equation. This equation is different from the inequality, and so this will be red. Let me change its color. That should be red for our answer. Okay, that goes to our letter B. All right, we already reached letter C, which is graphing. Graph the constraints and find the corner points. To find the optimal solution, you're looking for the maximum. Use your corner points. That's for letter D. Use your corner points to find the maximum profit. And then for letter E, what is the optimal solution? Okay, optimal means either maximum or minimum. All right, so we're looking for the maximum. Okay, and this will be the amount of acres that will be allotted for corn and potatoes, separate values. Okay, and all right, so that's it. Let's go back to our Desmos screen. We'll just get the worded problem and rewrite it there. Okay, so we're going to the other screen again. Okay, the previous problem is still there. We haven't erased it yet. Okay, so we're going to that screen, and then we shall clear this out. Okay, I'm just clearing our statements, previous statements, and then, all right, so let's put the problem over here. Okay, this will be over here. All right, so that's it. This is the third. A farmer has a field of 70 acres in which he plants potatoes and corn. So I believe we already finished that. So we just retype it over here. We have X for potatoes, number of acres, plus Y acres for corn, and this cannot exceed 70. There. All right. So we will have to adjust our screen. This time it's zoom in. Okay. We shall zoom in because it looks very tiny. Okay. It's just over here. Okay. Some more, some more. All right. It's very tiny. Okay. Probably one more zoom in. All right, let's stop there. All right, there. Okay, the 70 level is over here. The 70 level is over there, there. Okay, all right. And so we shall have this size. Okay, let me just clear that. Let me just erase it. Let me erase my writing there. Erase, erase, erase. There, okay, I was able to erase it. And then we already have the first constraint. This will be for the 70 acres. And the allotted area for corn and potatoes will not exceed 70. Okay, the next one will be the price for the seed per acre. And it will be $20 per acre for potatoes. And so our constraint will be 20 multiplied by X acres for potato. Okay, and then we will add the other one. Corn is 60 per acre. Okay, so this will be 60 per acre times the amount of acres for corn. Okay, and this will be in amount which is 3,000. Okay, all right, so this cannot be exceeding 3,000 there. Okay, all right, so this is it. All right, so maybe we can do a little adjustment here. All right, the seed for corn, 600 per acre, farmer, yes, 3,000 to spend on seed. All right, the maximum is 3,000. Let me enlarge that. I think I have encoded 300 only, one more zero. There, all right, okay. So that's it. It's close to the first graph, and we still have some more statements. The profit per acre of potatoes is 150, and the profit for corn is 50 per acre. Find the optimal solution for the farmer. Okay, we don't forget the area in acres cannot be negative. So again, we will still have to make use of X acres should be greater or equal to 0. Also, Y acres for the corn greater or equal to 0 there. Okay, all right. Okay, these are our constraints. We still have to make use of the profit statement P. Okay, the profit for potatoes is $150 per acre. So 150 times X plus $50 per acre for the corn. So 50 times Y there. This will be our profit statement. And we're going to make use of the corner points in this profit statement. So we already have our feasible region over here. You can see the feasible region starting from a 0, 0, going to this point, which looks like at this will be by 2. So that looks like 0, 50, and this will be like 30, 30, 40, and then over here is about 70, 0. And of course, back to 0, 0 there. This will be our feasible region, okay? And we have how many points? 1, 2, 3, 4, 1, 2, 3. Yes, only 4 points. And these are as follows. Okay, over here. This will be 0, 0. Okay, this is 0, 50. This point over here is 30, 40. Okay, and the fourth and final point is at 70, 0. Okay, we're going to compute one by one, starting from 0, 0. Of course, 0, 0 gives the minimum, okay, but we still have to write it. So P is equal to 150 times 0 plus 50 times 0. Okay, there. And there's the computed value. Profit is 0. Okay. All right, let's go to the next point. The next point is at 0, 50. There. Okay, 0, 50. And so we're going to make use of the same P statement. That's 150 multiplied by 0 plus 50 times 50. Profit is 2,500. Okay, going to the third point. Third point is at 30, 40. X is for 30 and Y is for 40. That means 30 acres for the potatoes and 40 acres for the corn. Let's see what we have for the profit. All right, so this will be again P is equal to 150 multiplied by 30 plus 50 multiplied by 40. Yes, that should be an open parenthesis and then 40 there. 6,500. All right. We still have one more point at 70, 0. Okay, one more computation. All right. So profit is equal to 150 multiplied by 70 plus 50 times 0. All right. Okay, that's it. All right. And it looks like if the farmer will have to plant potatoes all over his 70 acres, he will get the maximum profit. Okay, he doesn't need to plant corn. Okay, there. Okay, so maximum is 10,500 there. Okay, over here is the maximum. That's 10,500 compared to the other three. Okay, all right. So we computed all 4 points and we found 70 acres for potatoes and 0 acre for the corn. Okay, so to get the maximum profit, okay, the farmer has to plant potatoes, okay, for all his 70 acres. Okay, that's the maximum. All right, and so let us go back to our screen. So the answer is 70, 0 at 10,500. Okay, so we go back to our screen over here. Okay, so we continue with our answer. All right, we already did our constraints, and then to find, this is letter D, to find the optimal solution, you're looking for the maximum. Use your corner points to find the maximum. And we found it at 70, 0. There, okay? This is our answer, okay? This is our answer. Let me make that red. Okay, that's it. All right, and so what is the optimal solution? That's 10,500, okay? The maximum. Maximum P is equal to 10,500. And And let's put the unit, of course. This will be in dollars. There, okay? That's the maximum profit at 10,500. There. All right. Okay, that's it. And we found the maximum at 10,500 and 70 acres entirely planted with potatoes. All right, let's continue with the fourth and final problem. Okay, we have here impact printing makes two kinds of computer paper using premium paper or ordinary quality stack. They have a contract to supply at least 5,000 cases of paper. At least 5,000 cases of paper. When you say at least, it will have to be that amount or higher. Okay? All right, that amount or higher. There's only enough stock to make 4,000 cases of premium, but ample stock for ordinary paper. So for the premium paper, it is limited to 4,000. So it's from 0 to 4,000 cases for the premium. Okay, ample stock for ordinary paper. That means 0 to unlimited. Okay, all right. So that would be for ordinary paper. Next statement is both kinds are made with the same machine and 1,200 hours of machine time are available. Premium paper takes 18 minutes per case to make. Ordinary paper takes 12 minutes per case. Okay. All right. And so we will have to write the constraints first. All right. There's a hint over here. You need to convert the hours to minutes so that the inequality is all minutes. Okay. We will try that. All right. Letter A, write the constraints for the problem. Again, when we say constraints, these are the inequalities. Okay. The one with less than or equal or greater or equal. Write the constraints of the problem. Okay, let's start from the second statement. They have a contract to supply at least 5,000 cases of paper. And so we shall define our type of papers first. For the premium, let's use X. So we'll have to use let X for the premium paper. Okay, and then we have the Y for the ordinary. Okay, ordinary paper. Okay, all right. So this will be defining our letter variables. Okay, we shall denote this with red. There. Okay, letter A, write the constraints. Okay, here we go. We will start with contract to supply at least 5,000 cases. So we will have to use greater or equal to 5,000 because at least that means it can go higher than that. Okay. All right. So that means we have X and then added to the ordinary can be higher or equal to 5,000. Okay. Cases of paper. Again, the X will have to be small letter. This will be our first constraint. Okay. All right. We'll just color it later at the same time. All right, there's only enough stock to make 4,000 cases of the premium paper. It's limited to 0 to 4,000 cases, okay? And so our next inequality should be, all right, up to 4,000, okay? Up to 4,000. All right, we can make use of something like this. I wonder if the computer can accept that. 0 less equal. Okay, and then we have, we're talking about the premium and then less equal 4,000. There, it's something like this. Okay, it's something like this. So this is equivalent to X greater or equal to 0 and X is less or equal to 4,000. Okay, so we will have to do this in the graph later. All right, what else? Ample stock for ordinary paper. That would be for the Y. Okay, that means Y is greater or equal to 0. There. Okay, it can be more than that. Okay, and it can be more than 4,000. Okay, all right. So anything higher than 0, because we're talking about physical objects here, physical quantities. There cannot be negative. Okay. All right. What else? We're talking about the time. Both kinds are made with the same machine. Both kinds are made with the same machine, and 1,200 hours of machine time are available. All right. So the statements which will be used for this will be this part here. Premium paper takes 18 minutes per case. Okay. All right. So we will have to make use of 18 minutes per case, okay, to make ordinary, no, for premium, and then 12 minutes for the ordinary. Yes, there. Premium paper takes 18. All right, so 18 times X, and then we have 12 minutes for the ordinary. So 12 minutes times Y. And the allowable time is 1,200 hours. And so we will have to convert 1,200 hours to minutes. Okay, so to convert this, we will have to multiply this by 60. Okay, because there is 60 minutes per 1 hour. Okay, so it will have to be something like this. If we're going to compute this, it will be okay. Let me write it somewhere here. We have 1,200 hours. Okay, we multiply this. Okay, we're going to multiply this by 60 minutes. Okay, 60 minutes per 1 hour, right? 60 minutes per hour there. Okay, like that, 60 minutes per hour. And so hours and hours cancels out. Okay, and the unit here will now be in minutes. And this will be like 72,000 minutes there. Okay, so our equation, our inequality here will be 18 minutes times X plus 12 times Y, and this cannot exceed, so less or equal to 72,000 minutes there. Okay, this will be our constraints. Everything in minutes, so that's it. All right. Okay, so 72,000 minutes is the equivalent of 1,200 hours. Okay, that will be the machine time available. And then finally, we will have the profit statement. All right, let me just change this to red. This will now be in red there. Okay, this will be for our answers. That goes to our letter A. Write the profit equation. All right, I cannot see the problem, so let's go back. All right, the profit, the last statement, the profit on each is $4 per case and $3 per case, respectively. I think the $4 will be for the premium, okay, and $3 for the ordinary paper, okay. All right, so X represents the number of case. Okay, let's very specific here. All right, X will be the number of case of the premium type, okay, premium type of paper. There. All right, let's put the word type there. All right, and then the other one is ordinary. Okay, this will be the ordinary type, and Y represents the number of case of the ordinary type of paper there. All right, so that's it. And so we continue with profit, $4 for the premium, okay, and $3 for the ordinary, respectively. Okay, so this will now be it. 4 and 3. We shall write our statement, write the profit statement. This will be capital P is equal to, which one came first? $4 times X plus $3 times Y. Okay, let me see. Let me see again. Which one came first? 4. All right. So 4 for premium, 3 for ordinary. All right. So this will be our statement. This will have to be in red. Okay. Again, this should be in red. Let me change that to red. Oops. Let me change it again. Red. There. All right. It's red. All right. Next question. Graph the constraints. This is for letter C. Graph the constraints and find the corner points. All right. We'll be shifting screen at this point, but let's finish our reading for the remaining questions. Letter C is graph the constraints, and then letter D is find the optimal solution. And that's it. All right. So we're going to shift screen. All right. Let's go back to our Desmo screen and erase number 3. All right, let's remove number 3 first. Okay, it's clear. All right, let's, oh, we did not copy the problem. Let's go back again. All right, let me go back there. We did not copy the problem. Over here. Some more. Scroll up. Okay, let me get the problem there. Okay, and then we'll paste it in our Desmo screen. There. All right, let's put it in the usual space. Over here. There. Oh, it's too many, but we can adjust it later. All right, so we will just select that and move it. All right, there. It's movable. All right, so let's read the first part. Okay, impact printing makes 2 kinds of computer paper. All right. Second statement, they have a contract to supply at least 5,000 cases of paper. At least. All right, so that means we will start with premium plus the ordinary. We're talking about the number of cases of paper. And this can go over 5,000 because it at least. That means it can be higher than that. So we will not use less or equal. Instead, we will use greater or equal. And that's 5,000 cases there. And we cannot see the line at this point. All right, that means, let's check that, either zoom or zoom in. Let's go back to the standard. Okay, this is the usual. Okay, this is the usual. This is greater. That means we will have to do the zoom out. Okay. All right. We will have to do the zoom out because it's far out there. Our number is 5,000. Okay. Some more. There. Some more. Okay. All right. We're already in the 4,000. All right. There you go. It's found. Okay. There. All right. Okay. All right. So the 5,000 level is over here. The 5,000 level is over there. There. Okay. All right. Okay. So let's put the other constraints. Next. There is only enough stock to make 4,000 cases. All right. So that means 0 to 4,000. We try doing that in our screen. Let's see if it can be plotted. 0 is less or equal, and then we have this variable for premium, okay, and then less or equal, and that's 4,000. 4000. Okay, that's it. All right, that's the same as x less or equal. It must be less or equal. Let's put the equal there. Okay, there. So it's a solid line. Okay, that goes to the premium. There's only enough stock to make 4,000 cases of premium. Okay, that means it's from 0 to 4,000 only. Okay, But ample stock for ordinary paper. All right, for ordinary paper, it will have to be y greater or equal to 0 there. Okay, ample stock. So it's not limited. Okay, it's from 0 up to some positive value. Okay, and what else do we have? Let me adjust the wordings. Okay, because we cannot see the bottom. All right, let me see the bottom. All right. Okay, ample stock for ordinary paper. All right, both kinds are made with the same machine, and we have 1,200 hours of machine. Where we have reached the time. Okay, premium paper takes 18 minutes. All right, we have done this in the other screen, so we will have to make use of 18 minutes times X for the premium. Okay, number of cases, and then we have how much is that? 12 minutes for the ordinary, and we cannot exceed, how much is that again? 72,000 minutes, right? So it's less or equal 72,000 as far as I can remember the other screen. Okay, and that's it. All right, the profit on each is $4 per case. That goes to the premium and the premium paper, and $3 per case for the ordinary. That'll be for our profit statement. But our feasible region is very small over here. All right, we shall see our feasible region first. We will have to do zoom out some more. Zoom in. One more zoom in. There. All right. And, to make it a little larger. Okay. All right. Okay. First, we will have to determine the feasible region. Okay. It will have to be bounded by. Okay. This will have to be using the arrows. This will have to be going there. Okay. Like that. Okay. Because this region is going there. Okay. Supposed to be higher than 5,000. Okay. And then this boundary here is for the premium. This boundary here is for the premium. And the entire triangle here is inside. Okay. All right. Now, for the green, okay, this is actually for the time. Okay. This is for the time. Okay. This is for the time, right? All right. And so this is less or equal 72,000. So the arrow here goes this way. There. Like that. And so our feasible region will have to be only this portion. There. This is our feasible region. There. Okay. All right. So we're going to compute from these 3 points here. Okay. And the 3 points are here. One over here. Okay. One over here. Okay. And another down here. Okay. All right. So let us list these points. Okay. 0, 500. Okay. We have 0 and will that be 500 or 5,000? 0, 5,000. And let's place a label there. Okay, that's our first point. Another point at 0, 6,000. We use another field, 0 and 6,000 with a label there. And then for our next point over here, that's 2,000, 3,000 over here. 2,000 and 3,000 there. All right, with a label. Okay, so all right, we will have to compute using the statement. All right, using the statement, using this 3 points. Using this 3 points. All right, so let's define our profit statement. Our profit statement's capital P is equal to $4 per case. That means 4 times X for the premium plus $3 for the ordinary. So that's times y there. So our profit equation is P is equal to 4x plus 3y. $4 times x plus $3 times y. All right. And so we have our next part. We shall compute using the 5,000. Okay. All right. So capital P is equal to 4 times 0 plus, okay, that will be 3 times 5,000, like that. Okay. And our profit is 15,000. All right. Let's have another. P is equal to 4 times 0 again for premium plus 3 times, this time we have 6,000. There. Okay, we have 18,000 for this point. Let's use the third and final point. This will be $4 times 2,000 plus 3 times 3,000. There. Okay. All right. And so it looks like we have the second point for maximum. Okay. That means there should not be premium type. Okay. There should not be a production of premium type. Only ordinary type of paper will provide a maximum profit. That'll be at 6,000 cases for the ordinary type. Okay, because our maximum is right here, this point here, there. That's a maximum, 6,000, which gives us a 18,000 maximum profit. A difference of 1,000 only compared to the 2,000 and 3,000 over here. Okay, so our answer is 18,000 maximum profit. Okay, all right. So let's go back to our screen. Okay, so our maximum is 18,000 at 6,000. All right. So let's go back there. Let's go back to that paper. Okay, we're now doing the. We're done with the graph, and so we shall have. Okay, we're done with letter C, graph. Okay, and we have the corner points. Okay, so the corner points will be at how much is that? 5,000. Also, we have 0 and 6,000. Also, we have 2,000 and how much is that? 3,000, like that. Okay, we can always check it out again. We can always check that out. 2,000, 3,000. All right. Okay. 2,000, 3,000. Okay. But that's not the maximum. Okay. That is not the maximum. All right. So that's 2,000, 3,000. These are the points. Okay. These are the points. Okay. And we shall transform it. Okay. Let's make it red. It should be red. Okay. For our answer. All right. And letter D, find the optimal solution. Of course, our optimal solution, it will be zero case for premium and 6,000 cases for ordinary. Ordinary, yes, ordinary paper. Okay, there. This will be for our answer. Of course, we still have to compute for the maximum profit, and the maximum profit, okay, the maximum profit is 18,000. Okay, all right. So let's put it on top, Let's put it on top over here. That'll be a maximum of 18,000 there. That's the maximum profit. 0 case for premium type and 6,000 cases for the ordinary type of paper. That provides the answer. Okay, there, and that's it. Okay, we have the answer for all the numbers. Okay, and you were able to check the answers from desmos.com file. Okay, so make sure you know how to make use of the desmos.com. All right, so this is actually the maximum there. Okay, that is the maximum. And you will have to make use of ordinary paper and do not use the premium paper. Okay, all right, so this is the final answer for number 4. Okay, all right, and so I hope you were able to learn from our examples. This will be it for now. See you later.